So this time, the question says, write as a single logarithm. This is the same as simplify. So it is a very important skill to take a bunch of logarithms and put them together to a single logarithm. And you can do this every single time. So in A is interesting because students see plus and they say, oh, adding is the product law. And I'm going to write out the product law right now, just exactly as we have it up on the board over there. Because log laws are very, very fussy. They're fussy in that if something is not matching up perfectly, you cannot use them. So look at that first one. There's something that doesn't match up perfectly that does not allow me to use my product law. What's the problem in the first one? Looks like I'm adding. I have the bases the same. Where's the issue from what's written here in green and what we have in part A? The 3. The product law only works if you have one log plus one log. I have a log and then I have a 3 in front. So that's a problem. So if you have a problem, the question is there a way to get rid of that 3? Yes. We have another log law that says anytime you have a number out in front, you can move that number where? In as an exponent. So step 1 in this question is I would have to use my power law first. That a number in front of a log can move in as an exponent. And then I have a log plus a log with the same base. Now I can combine these by multiplying, and I have a single logarithm. Your log laws are on your formula sheet, but they must be memorized. Because you're going to work with them so much, you don't have time to keep flipping back to your formula sheet saying, which one is this again? You need to have them memorized so you can recognize them quickly and know how to move fluidly from one side to the other. Writing as a single logarithm is going to be key later for solving logarithmic equations. All right, B. We have a log plus 2 logs minus 4 logs. So I see adding, I see subtracting, I see numbers in front. Notice that your adding law and your subtracting law, your product law and your quotient law, only work if there's ones in front, or 1 log plus 1 log. So our very first step here in this question will be to take those numbers out in front and put them in as exponents. Now, I could do this in 2 steps, but I'm going to show you a very useful shortcut that you're going to use all the time that's actually better and always works. So if you've got a single log like we do here for each of them, and you're adding and subtracting, you can do your product law and your quotient law all at once. And it looks like this. Whichever ones are positive, the log x plus the log y squared, they will be put together in your numerator with your product law. And whichever ones are subtracted, they will be put together in your denominator with the quotient law. So I'm going to add to this question a b.5 for C. Log A minus log b squared minus log C plus log f cubed plus log h. If you had all of these, they're all single, 1 log minus a log minus a log plus a log plus a log, you can do the product and the quotient rule all at once. And in fact, if you tried to do it separately, chances are you would make a mistake. So which ones are positive? The log A, the log f cubed, and the log h. So I will have a f cubed and h multiplied together in my numerator. Which ones are negative? The b squared and the c. So I will have b squared and c multiplied together in my denominator. So you will use your product and your quotient rule with big ones all at once because it's way more efficient, it's easier, and you will make less mistakes. But you'll notice that every single time so far when we want to combine as a single logarithm, we had to move the numbers out in front in as exponents first. That will always be our first step. And then in C, we have log 2 of 6, and we are trying to combine as a single logarithm, but we just have a single number here. So just like we were doing before, off to the side here, I want you to think this. Could I change 3 to a log with a base of 2? What would have to go in the box? An 8. So log base 2 of 6 minus 3 is log base 2 of 6 minus log base 2 of 8, which is equal to log base 2 of 6 divided by 8, which is the same as log base 2, 3 divided by 4. This unit is a multiple choice maker's heaven. Because I could start with this, and you would have to make it equal to this, right? Or I could then take that and use my log law and say this. Or I could take that and change it to a 2. Did you know that log base 2 of 6 minus 3 is the same as log base 2 of 3 minus 2? If this was multiple choice and this was the answer for what's equal to that, that would be like, where'd that come from? And it's all about manipulation and using your log laws. So I changed 3 to log base 2 of 8. That allowed me to combine as a single log. This is a correct answer. And if you left it like this on a test, on a short answer question, 100%. You don't have to reduce fractions. But you could reduce the fractions to 3/4. And then you could use your quotient law to say dividing is the same as subtracting. And then you could say, well, I know 2 to what exponent is 4. I could change that back to a 2. And we could get something completely different than what we started with. Okay, questions to circle on this one. 5, 8, 11, and 18.